Hello viewers, welcome to the first video of this C++ channel. I intend to talk about various aspects of C++ programming language, including modern C++ and occasionally regarding legacy C++ as well. If you're intending to learn C++ or to refresh your knowledge about C++, regardless whether you are a newbie or an intermediate developer or an expert C++ developer, this channel is for you and you should subscribe the channel. So I would like to start off with an overview of C++ in which I would like to talk about the history of C++ and how it began and what has been the various journeys along the way when it comes to various standards and so forth, and what's the modern state of C++, and what are the supported compilers and some resources for you to start off learning C++ as well. So that's what I'm going to do in this video. So let's get started. A little bit of a history of C++. C++ was invented by Bjorn Strostrup at AT&T, and the original intention of the creator was to provide a similar type of programming language. Simula is another programming language that has been widely used then. So the author or the inventor wanted to develop some facilities, and he wanted to add such facilities to C programming language and enhance it. So initially, he started developing this in 1979, and he then first called this thing as C with classes, and then at some point it was also named as New C, and it had classes, constructors and destructors, derived classes and so forth. And if you don't understand what I'm talking about in terms of constructors, destructors, don't worry, this channel will take you through those aspects in a slow and steady fashion in upcoming videos as well. However, at some point later, someone named Rick Messity proposed Bjorn Strostrup to call the programming language as C++ instead as C with classes or New C, probably because it kind of made the old language a little bit awkward sort of situation, to make it sound like it is like outdated or so forth, which hasn't been the case over the decades. C is still a very widely used language and one of the topmost languages used in various aspects, and it's one of the popular languages as well, and in various indexes it comes as the first or the second or the third in the most case. So it's by no means an outdated language. So it was a right decision to call it C++ rather than calling it as C with classes or New C. So even though the development started in 1979, it was first made commercially available in 1985. So you can see it has taken quite some time, like about 6 years, to get to commercial level. And so having the first commercial release in 1985 aside, it became a standard, and there was a first standard released in 1998. Another 13 years went by to standardize the C++ programming language. However, in reality, in the early 90s, and there was some standardization effort started by American National Standard Institute, ANSI, and in the early 90s, but then it was consolidated as part of ISO standard, and that was ratified in 1998. And right after that release, I won't say right after, and maybe a couple of years later, the work for a newer standard began, and in the at the time called it C++0x, and because they thought, okay, they'll probably be able to ratify a new standard somewhere in the 2000s, before 2010 or 2011, right? And however, that didn't quite happen, and as you will see in the next couple of slides. And anyhow, in 2003, they released a bug fix release 5 years later, surprisingly, for the 1998 standard, and officially it was called C++03. However, that was nothing more than C++98, and C++98 plus some bug fixes is what C++03 was, right? And anyhow, once that was done and more work was carried out for C++0x, however, the committee could not ratify a standard before 2010 to call it either C++09 or something like that. So they had to wait till 2011, and they ended up calling it C++11 standard. And it was formally approved in 2011. And it was a major advancement to the C++ programming language in terms of various features and functionalities that got added in that particular standardization effort. However, right after that, the committee was so much in a marathon mode, sort of, and they kept releasing newer standards, namely C++14, C++17, 20, and the current standard is C++23, and the next standard will most probably be C++26, and the work is in progress at the time of the recording of this particular video. Right, and so let's talk a little bit about C++ ideals from the creator himself. Wanted the C++ to be capable of doing direct mappings of built-in operations and types to hardware to provide efficiency when it comes to your programs and so forth. And so these particular points I extracted from the author's book called The C++ Programming Language, the 4th edition one. And if you're going to be a C++ developer, at some point you should be reading this book as well, if you're serious about it, and I highly recommend reading it. But I'll come to some of the resources that you can follow, some of the books that you can read to start off with C++ at the latter part of this video. And but keep in mind that this book is something that you should be considering reading at some point. Another C++ ideal was to make it affordable and flexible abstraction mechanisms to for the programming language to have those abstraction mechanisms, and that was one of the ideals as well. And also which was one of the ambitious ideals, was to leave no room for lower level than C++. So it's like the lowest point that you can touch in hardware, you can do it in C++. There can be another programming language that could do anything lower than C++ could do. So that was the ideal, and so it just gives the developer quite a lot of freedom and also power to make maximum use of hardware for various optimizations and abstractions as it comes necessary. And also another ideal, which is kind of a very popular ideal for C++, is you don't pay for what you don't use, and so forth. So this is something that you will also learn as you work with C++ programming language. One of the popular thing is it doesn't have a full-fledged garbage collector like some other languages like Java, C# and so forth, which is something that could kick in at random times, so which is not in control of the developer. So that's something that C++ doesn't support by its ideal, where you don't have to suffer from various performance aspects, which is something that you didn't intend for in the first place, like when you develop your code and so forth. And again, if these jargons of programming like garbage collection and various aspects that I'm talking about is a new thing for you. Don't worry, we'll be learning those things in upcoming videos in due course. So let's talk a little bit about what styles of programming that C++ support. C++ obviously support this notion of procedural programming because that's what C supported, and initially C++ was just some additional features around C, which is why it was called C with classes and new C and so forth, right? So it still supports that procedural programming. If you want to stick with that style of programming, you can still do that in C++. And it supports the data abstraction style of programming, of obviously because of classes and various other you know modules or models that C++ support. You can accomplish data abstraction, as you will see in future videos as well. So it also supports object-oriented programming, again something that classes support, because classes is a way of making a blueprint of an object. So you think various aspects of your problem as a set of objects and operations around them. So it supports object-oriented programming. So you can apply double OP in a shorter form. You call it double OP using C++ as well. C++ at a later point, I think by the time the 1998 standard was ratified, it started supporting this concept called templates, which is what the base of generic programming. So what generic programming in simple terms means, like you can have certain functionalities implemented regardless of the underlying type of that you want to make that functionality available, so that you make that functionality a generic functionality. That's why you call it a generic programming. And for example, you want to do some, let's say, additions. Usually you can have a function with additions with integers, but the same can be applied for floats, doubles, and various different types of data types. Can even be applied for a user defined data type, and that's what generic programming means. Again, if it's new, don't worry, we'll be talking about those in future videos. So C++ also supports template meta programming. This notion is not new, but the word can be little confusing for even expert C++ programmers, intermediate level C++ programmers. So template meta programming, in a way, it is about compile time acts of compiler that makes generic programming a meta programming language, so that at the compile time itself it will deduce the types and make very good optimizations that can be applied at the runtime. So I won't go further into the definition of template meta programming at this point. So just remember template meta programming as an aspect of generic programming, and you do programming at the compile time so that your compiler can help you do better at the runtime. So that's template meta programming. C++ also supports functional programming styles. It's somewhat a newer jargon, but in computer science point of view, it is by no means new. It's been around for decades. But I think the style being applied for commercial use and for industrial use had been something that picked up very recently. So you would have heard about these functional programming languages and so forth. So C++ also supports functional programming style with various building blocks that it has. And it's not a fully functional programming language, but it supports the notion of functional programming in certain aspects. Right. So some facts that you should know about C++ is C is indeed a subset of C++, with minor exceptions, of course, because C language is also now very much controlled by a committee, just like C++ as well. So these two committees are trying to make C and C++ very much compatible, but there have been historically some differences between the subset of C in C++ versus what is actually now supported in C and so forth, right? So that's why so we have mentioned C is a subset of C++ with minor exceptions. But in a higher scale, in a larger scale, you can consider C as a subset of C++ in the most cases. And also, having said that, you should also remember that knowing C is not a prerequisite to C++, because C++ contains all that's what C contains, and you can right away pick up a C++ book and start learning C++, rather than thinking that you should first start with C and then come to C++, right? And also the other fact is, the language itself is quite large, and it also has quite a considerably large standard library as well for your common requirements for programming. So let's talk a little bit about individual standards that I already mentioned, the C++ 98, C++ 11, 14, 17, 20, and 23, and so forth, and what features that it added over the years and so forth. So to find a comprehensive list of such features and what features got removed in each standard, all that information you should consult the documentation that's available online on various websites. You should consult that, but I'll try to kind of give you a high level understanding of what has happened over the years in these standards in due course. So C++ 98, and as I mentioned, ANSI committee was convened in 1989, and it became part of the ISO in 1991. So anyhow, even though it became part of ISO in 1991, it took another 7 years for the standard to be ratified properly, and so that C++ 98 to be available as a mainstream standard for compiler implementers to implement a C++ compiler. And it had C++ 98 itself, like at that time itself, you had all the most used notions of C++, such as the classes, templates, namespaces, runtime type informations, RTTI, all that, right? So again, these don't worry too much about these jargons if you aren't aware of these. We'll learn about those in future videos. And in C++ 98 itself, there had been quite a large standards library, apart from something called STL, Standard Template Library, which had a library based on a lot of templates, and it's a collection of various common data structures and algorithms and so forth, so which you will mostly be using in your programs, most of the time. And it has been the most important addition in C++ 98. And it had things like strings and IO streams. So these are nothing more than libraries to do various IO operations and string manipulations when it comes to IO stream and string respectively. And as I mentioned, there had been a bug fixed release in 2003, and it was named C++ 03 at the time, and even though it was still C++ 98 with minor additions. And C++ 98 at that time itself, C++ didn't have a GUI toolkit or a library. It didn't have a database access library or a web application support. And for your surprise, C++ 23 current standard also doesn't have any of these functionalities as well. And you will see the reasons for that, because these are not like fundamental aspects in programming. So you could have libraries, and there are some very cool libraries available for database access, for web application development, as well as for GUIs as well. So the next major standard was C++11. As I mentioned, it was one of the standards, as I consider, that kind of revolutionized C++ as well, and it made a big difference between and sort of a cutover from legacy C++ to modern C++, and it brought a new experience to C++, and it almost made C++ look like a new language. But one of the good things about even this standard, even though it was revolutionary, is that there hadn't been any backward incompatibilities. And in C++11, concurrency support was added, and surprisingly, up until 2011, C++ as a standard mechanism didn't have support for concurrency, and it had to rely mostly on system libraries in various operating systems. Fortunately, those system libraries had been mostly developed in either C++ or in C, which C++ could leverage, right? But it has been properly formalized in C++11. A lot of influence from this other library called a community-driven library called Boost C++ libraries, and it's mostly a production-grade, high-quality library that this project started, I think, probably in early 2000s or so, and most of the libraries and notions that you see in modern C++ have been influenced by the Boost C++ library. And C++11 added these other concepts called move semantics, range-based for loops, and many more actually. So, and it then had this other thing called smart pointers, and again you will be using a lot of smart pointers in modern C++ code. But prior to 2011 standard, you probably had to rely on yourself allocating memory for your dynamic memory, and then making sure that you release such resources in due time, which is kind of eased out in smart pointers, as you will see in the most part. And then threads library, of course, with concurrency support, async programming support was added in C++11, and then some other very popular library modules like regex for regular expressions, and then tuple for having a construct that could kind of compose multiple types of values were added, and so forth. So we'll talk all about these in future lessons. And C++11 also brought in lambda expressions. So lambda expressions had been there in the computer science point of view for a very long time, but unfortunately C++ didn't have the support as a standard until C++11 standard came out. Right, C++, of course, 14, nothing like the C++ 03 from C++ 98. It was not just a bug fix release, but at the same time, it didn't kind of bring like groundbreaking functionalities into C++. However, some very important things were brought in, especially when it comes to making programming quite easier. And it brought in things like std, make unique function to create some types of smart pointers quite easily, and compile time integer sequences and so forth. Again, my intention is not for you to understand each of these features and think about, okay, these are the additions, but I'm just mentioning about these things for the completion, and also for you to taste about how the development happened over the years with C++. And Yeah, so I'll skip the other ones. And C++ 17 was again a major release, and it had quite a lot of things added. Uh, so, for example, things like lambdas, capture this. Again, it's something a development over the lambda expressions, and some nice to haves for lambda expressions which were not available in C++11 was added with C++17, and nested namespaces, inline variables, and more have been added in C++7. And also, some features were removed as well. So, even though smart pointers were properly introduced in 2011, there had been some attempts of doing certain automatic pointer manipulations even in C++98, but a less prudent manner, right? And one of that was this thing called the auto pointer. And so that was, officially removed as part of C++17. And so if you are using modern C++, you cannot use this functionality, and you shouldn't anyway, because that's something that hasn't been designed properly. And some of the features also made deprecated, which meant at C++17 time that future C++ specifications or standards will be removing such functionalities as well. So for a complete list, you should refer to online references for C++ for various standards. And C++17 brought in some cool functionalities into libraries like std-any, string view, file system support. Again, if you are to manipulate the file system in C++, previously you had to rely on operating system specific system calls, and and it was something that C++ developers have been longing for quite a lot of time, quite a long time, in my opinion, including myself. So I was so happy to know that C++ added this std file system functionality for you to create directories, create files, check for the status of the file, delete files, move files, all those common file operations that you think of doing is now supported with C++17. C++20 brought four major features. So in that sense, it is yet another major C++ standard, in my opinion. So it brought in this support called coroutines. So if you just search coroutines in Google, you will see all the papers. Like, it's not a new concept. So coroutines are a mechanism for a particular function to pause and resume in a simple way. I just made it very simple for you to understand, but there's a lot more to coroutine than just that definition. But you can just think of it in a way that you can at some point pause your runtime to hold everything up to that point and then resume at a later point, and that's what coroutine brings to the table. But otherwise, for such functionalities, you have to design a proper concurrency model, which is inherently a complex task to do. And then C++20 also brought something called concepts, again something that goes along with templates. And in templates, you can give more conditional nature for templates, and it's sort of something that enables template metaprogramming in a way as well, so which we will talk about later. And it also added something called rangers, and one of my favorites, which is the modules. So modules is a way to make C++ compilation quite faster. It's not just that, but that's one of the goals of adding modules. Like, inherently, larger C++ programs tends to take longer time to compile for its compilation strategy that it had since its inception. But that is now changed with modules, and again we will talk about what modules are and how that can help reduce compile time. But at the same time, I should also mention you can still program your C++ without modules, and that support of programmability without modules will unlikely to go away from C++, which means if the standard committee does that, which means that it will be losing the backward incompatibility. So in that sense, in this particular channel, we'll be talking about both module based development and also the other type of development, which for your purpose of knowing, it's basically including your preprocessors for various functionalities to be used in your programs, and we will be using those interchangeably, and mostly we'll be talking about that because that will unlikely be removed in C++. So C++20 also brought math constants in libraries like pi, epsilon, and so forth, and concept libraries and many other functionalities for string manipulation and so forth. And some of these might sound like very much rudimentary, and yes, there have been ways that you could achieve these things in C++ in different ways, but having such easier mechanisms makes the life of a developer easier, and that's what C++20 brings in to the table. And then we finally come to the C++23 standard, which is the current standard, and it brings attributes support for lambda expressions. But again, you might not know what is an attribute, and we'll talk about those things when we talk about that functionality. And that's again, attributes are something that modern C++ brought into the mainstream, and now that concept is applicable to lambda expressions as well. And literal suffixes for various types of data types and so forth, so those will be supported. And one of again, something that I haven't personally looked at, but wanting to look at, is this stack trace library, which has been something that C++ have been missing for ages, and some other languages like Java, C# and so forth inherently had this thing from their initial releases itself. And C++23 also brings some other things like resize and overwrite, and string support for things like contains, to see like a particular substring is available in a string and so forth. These were traditionally been implemented in different mechanisms in different libraries, and sometimes in your program you would implement in your own way and so forth. Right, having covered all the C++ standards up to the latest standard, C++23, in a quick fire manner, so let's talk about where C++ is used today. C++ can be used to develop different types of applications, and mostly the C++ inventor himself likes to call it a systems programming language, which means a programming language that sits closer to the hardware and to support developing applications that require such abstractions for hardware. So applications like operating systems, drivers for various hardwares like your a graphic card and things like that, right? Or the network interface and so forth. And you can use C++ to develop virtual machines, compilers for various different programming languages. If you intend to create your own programming language, you will have to create a compiler. And C++ is a good choice to create a compiler, although it is not the only option, but mostly you can use. And various browsers have been developed in C++, like all the modern browsers that you know about has something to do with C++, including Google Chrome, Firefox, the Microsoft Edge, and so forth. And C++ can be and is used for game programming, especially because games require hardware level access so that it doesn't have glitches when you play games, right? And doesn't suffer with performance and so forth. And most high performance games are mostly developed using C++. And it's one of the strong areas of C++ as well. So C++ is also used for financial applications where microsecond, nanosecond type of times can make a big difference, such as in stock trading platforms, derivatives markets, capital markets, and so forth, and brokerage applications. And those applications are usually developed in C++. It's a popular choice. It's not just developed in C++. There are other options, but it's one of the popular choices. And you can also use C++ for embedded device applications. Like, let's say your car might be having a very good system for various operations, like navigation, audios, videos, radios, and you name it, right? So the software that is running behind the scenes of that device is most probably running C++, and it's one of the popular choices again. So that kind of applications. And desktop applications, I don't get a lot of people talking about desktop applications with C++ much when it comes to what C++ can be used for, but in a way that I have seen most desktop applications are developed with C++, or it is developed with some other library which under the hood uses C++, so that it gives a wrapper for different programming languages, and you use that language to develop your application, but under the hood it's using C++ for development and so forth. For example, one of the popular libraries for GUI development is something called Qt. And Qt, for Qt you have wrappers for Python and various other programming languages as well. So it's just an example to throw out. And C++ is now used for artificial intelligence, for AI and machine learning models as well, because for machine learning and large language models that you might be hearing nowadays a lot requires extensive power and also a very good performance when it comes to analyzing large data, right? And for such purposes, C++ is an ideal choice as well. So let's talk a little bit about C++ compilers. For you to develop C++ applications, you need to install a compiler in your machine. So depending on what operating system you use, what systems you use, what compilers options that you have may differ. But these are the common compilers that many books are based on, and many applications are actually developed on, and so forth, right? So one of the most popular C++ compiler is what is called as G++, which is part of the GCC, which stands for GNU Compiler Collection. And initially GCC stood for GNU C Compiler, but later it became a collection where GCC then added support for compiling various different programming languages, including C++, Java, and different other programming languages, right? So it became a GNU Compiler Collection. And the C++ compiler is what they call as G++, is one of the popular compilers if you're specifically targeting Linux, Unix type of operating system. But it's also available for Windows in various other forms, but in Windows, obviously the first choice is Microsoft Visual C++, which is the Microsoft version of Microsoft's C++ compiler, which they call as Microsoft Visual C++, or you sometimes in literature you will get to know that as MSVC and so forth. Another very important compiler nowadays, and which became into mainstream quite faster, is this compiler called Clang. Some people call it CLang, but it's Clang. And the C++ compiler is Clang++, and this is based on a technology called LLVM. And LLVM doesn't stand for anything, but it's a very smart technology to compile various different programming languages to an intermediate programming language, and then that platform supports generating machine level code for various different CPU architectures and so forth. So I'm not going to talk about LLVM in this particular video in greater detail, but Clang is based on LLVM, so that's the only thing that you might want to know about. And there is if you're a Mac user, it's most probably when you install, we'll talk about various different compilers and how to install and how to use that thing in future videos. But Apple Mac has its own Clang fork, and they support their own compiler based on Clang. Clang is an open source compiler, so Apple uses that underneath in various tools that it has as part of it. However, if at all possible, I recommend that you use Clang base compiler itself if possible, but there's nothing wrong in using Apple Clang as well. So having said that, we come to the conclusion of this initial overview of C++, and I would like to wrap this video with by providing you some books as references for you to start off learning C++. Based on your experience, where you can start is different, and to be honest, C++ had been around for nearly 45 years, since 1979, right? And there have been hundreds and maybe possibly thousands of books written on C++. So literally giving you or name dropping some books may be unfair for other books, but these are some of the books that I have come across and I have read at least in at least a few chapters, right? So I won't claim that I have read all the books mentioned here, but something that I found can be applicable for you as well. So the first one that is on the far left is called C++ programming language, is by the inventor himself, Bjorn Strostrup. This book is, however, not a beginner friendly book in my opinion. It might be, but if you're a newbie, don't start with this, because by the time you read the first chapter, you probably will exhaust yourself and then give up. And in that sense, I don't recommend reading this book if you're a newbie. If you're an intermediate developer or an expert developer of C++, you should certainly at some point start reading the book as well, so that you get to know about the C++ design concepts and various aspects from the inventor himself. So this other book that you see on the professional C++ book is something that you can consider as a newbie book. It's also applicable for intermediate developers as well as expert level developers as well. So that's a book for everyone. So even if you're a newbie, if you want to go ahead with that, it's a good book to start off with. And similarly, the next book as well, The Beginning C++ 23, and that especially covers the modern C++, the latest standard. So if you want to start with such things rather than thinking too much about how C++ had been evolving over the years, and you just get down to business right away and you just have to focus on the latest one, so go ahead with this Beginning C++ 23. This other book, C++ 20 for programmers, is based on a popular book called C++ How to Program in C++ for Programmers, and there is a series of other books for other programming languages as well. It's also a beginner friendly book. If you want to, you can go ahead with that book as well. But it's more academic oriented, like if you're specifically following a course or teaching a course, like me, for example, in this channel, it would be a good book for you to start off and start reading. If your semester or if your course for C++ is just 1 month or 2 months or 3 months, all these books are like hefty books with possibly 600, 700 plus pages. So don't expect that you can read all the pages for you to get along. and there are some good online materials if you want to do such a course and do well in the course, of course. Then better you look into such other materials along with these materials, but it's good to start off with these materials as well. And the book on the far right is The Complete Reference C++. It has been one of the very popular C++ books, and unfortunately it has not been updated with modern C++, including C++ 11. So this book that you see covers C++ 98, but why I included this book is it's so much beginner friendly. Like it's for newbies, and you will have no trouble reading the book. And it starts off with giving you some understanding about the C programming language, and gradually taking you to C++, starting with C constructs as well, which is a very good book. But if you're a new developer who wants to learn about new modern style of C++, don't start with that. But if you already know those concepts and you know the difference between the functionalities that are available in the modern C++, and you know how to compare that with older C++, then if you want to refresh and think about what's been there in previous standards, and if you want to know it in a very freestyle manner, go with this book. And it's one of the best books that I have read in terms of C++. It's a book that I learned C++. That's I can put it that way. That's why I included that book. And on the bottom row, you see two books, Effective C++ and Effective Modern C++. And so these two books, again, as the name says, it makes you an effective C++ developer. But again, these are not beginner-friendly books. I don't recommend reading Effective C++ if you are just starting with C++. I think that's a book for intermediate developers. Like once you know and once you have developed some C++ applications and you have made your hands dirty with C++ very well, and now you need to know about various aspects, those missing pieces that you might have missed when it comes to learning C++ with elementary books. This is a book that you need to read, and which will give you a lot of ground, and which will make a lot of things make sense for you. And it's a good book, definitely. And same is applicable for Effective Modern C++, for modern concepts of C++. And Effective C++ is mainly targeted with C++ 98, and it's pre-C++ 11 era, but it just touches on some C++ 11 aspects because probably the book had been written around that time, so it has some ideas of modern C++ as well. So having said that, we come to the end of this video, which is the first video of this channel, and which had been a little longer, but it all makes sense, and we should all know about how C++ evolved over the years. And I truly think that you become a C++ expert with the support of this channel. And I myself is continuing to learn C++ and every day, and I program with C++ most of the time with various projects. So I want to share my experience with C++ in this channel, and I really hope that will find helpful for you as well. And I strongly recommend you subscribe to the channel and get notification and learn about C++ in future. So see you soon in next videos.